Work done on an object by a constant force F, W index F, is defined as the inner product of force and displacement vector D. For instance, if this is the horizontal surface and an object is located on it and a constant force F begins to act on it and the object begins to move on this horizontal surface, the direction of the constant force makes angle theta with the direction of the motion of object. Now, if the displacement vector of the object is this vector D, the work done on the object by this constant force is W index F, that is equal to the magnitude of force times magnitude of displacement vector times cosine of theta. This can be written as Fd cosine of theta if F and D in this relation are the magnitudes of vectors F and D. Now, if F is a non-constant force, acting on an object through its travel from point 1 to point 2 on this path, where the position vector of the object at point 1 is this vector R index 1. If this point is the origin of the coordinate system and the position vector of the object at point 2 is this vector R index 2. At a given point on the path, for instance this point, the position vector of the object can be defined by this vector R, and the force acting on it can be this vector F. Although F is a non-constant force, but you can assume that for a very small displacement of the object through its path, it stays constant. So, for a very small displacement dr, you can assume that F is constant. So, the work done on the object through its very small displacement dr from this point to this point is equal to the F dot dr. Now, if you find the integral of this relation from point 1 to point 2, that is W equals integral of F dr from initial position vector R index 1 to the final position vector R index 2, This relation will give you the work done on the object by this non-constant force through its travel from point 1 to point 2.